Hello, everyone. I am re-recording the end of video for section module 2.3. Sorry again for the the sound going out on that. I remember that happened when I recorded it, and I had thought I had re-recorded it, but apparently I did not. So we're going to go through the end of this, and then I will also have a separate video with an example of another dimensional analysis problem. So this is picking up towards the end of that same PowerPoint. I want to talk a little bit about derived units. And derived units are related to this idea of conversion factors in that we are using the units to guide what we do. In a derived unit, we have a unit where we have more than one unit present in the measurement. So things like area and volume are examples of this, as well as density and speed. So we're showing, so not just 1 centimeter, but centimeter times centimeter, or centimeter times centimeter times centimeter, or gram, and something else. So we're showing miles and hours. We're showing more than one unit together. And these are the types of things that we've seen are very helpful as conversion factors sometimes. So we've seen how we can use something like this to cancel out units. There are some specific things, though, we do need to talk about related to this that we have not seen before. Specifically, when we have units raised to a power, we have to do some additional things, consider some additional things when we do this. This will be very important in lab this coming week. When you are converting between units raised to a power, you also need to raise the conversion factor to that same power. So we'll look at an example of how that would work. So let's say we want to have a conversion between square inches and square centimeters. Well, first of all, this is the conversion between inches, centimeters and inches. You don't have to memorize this one, but I'm just providing this so you can see how this works. So 1 inch is equal to 2.54 centimeters. Well, if we were to not just have inches and centimeters, but square inches and square centimeters, that will change this conversion. So when we square it, we're squaring the whole thing, not just the centimeters, but the number that goes with it. Okay, same thing over here, squaring the whole thing. So not just the inches, but the number that goes with it. In this case, squaring 1, we just have 1, right? So that doesn't really change anything. So you have 1 square inch. But over here, instead of having 2.54 centimeters, we have 6.54 centimeters squared. So we took this 2.54, squared it to get this number. So this is important anytime you have a unit raised to a power, that you are able to perform this this type of conversion. And again, we'll see some examples of that in lab this coming week. I want to talk about a few specific examples. We'll look at one now, and then one we'll wait until module 3. So the first one is volume. So volume is a derived unit. And we looked at area on the last slide. In chemistry, we're often going to be more interested in volumes, as we'll see in lab. So here we're looking at kind of a representation of maybe measuring volume. So we have this cube, and each of these little squares is 1 centimeter. Don't worry about what a decimeter is for now, but each of these squares is 1 centimeter. So if we count across, we have 10 centimeters across, and then we also have 10 centimeters going back here, and then 10 centimeters going out. Okay, so we have 3 dimensions here. We have the up and down, we have the forward and back, we have the left and right. Okay, so 3 different dimensions in a volume. So when we do a conversion between units here, we have to be aware, as we saw on the previous slide, that it's not just the unit, it's the conversion between them. Or it's not just one unit, it's that you have 3 different dimensions. So let's look at how that works. So we know that 1 centimeter is equal to 1 times 10 to the minus 2 meters. And then if we do a cubic centimeter, we have this dimension, this dimension, this dimension. Okay, so we would do, this would be cubed. Okay, and another way to think about this is if you're counting how many total little cubes you have here, you have to count the 10 here, and then multiply it by the 10 here, and then multiply that by the 10 here. Okay, so what that ends up giving us is that in 1 cubic centimeter, we have 1/1,000,000th of a cubic meter. Okay, so you're cubing that, that conversion factor. Instead of doing that, this is a big deal, so talking about 1 part per million is kind of a very small amount. We don't like to deal with very small numbers like that if we don't need to, and yet the cubic centimeter is not the ideal measure in many cases. So this is where the decimeter comes in, and you don't actually have to remember cubic or decimeter or cubic decimeter, but it's essentially 10 centimeters is a decimeter. So what we do is we take this sort of intermediate value and we say, okay, we're going to say this thing means something. So 1 cubic decimeter is 1 times 10 to the 1 meters cubed. So we get this, and we're actually going to redefine that as a liter. Okay, so I said don't worry about what a cubic decimeter is. That's a liter. So from now on, we'll talk about that as being a liter. And because we're defining the liter as a measure of volume, we can then also use the prefixes we've been talking about. So the milli prefix, for example, and say 1,000 milliliters is the same as 1 liter. We don't have to do this kind of crazy cubing thing because we're defining this as a volume. Now, because of the way we defined it, it so happens that this is also equal to this. Don't worry too much about this part, but kind of what we're seeing here and here is that we would have 1,000 cubic centimeters here. Okay, so the takeaway here, and if you don't understand the decimeters cubed, if you don't quite get all of that, it's not a big deal. What you want to remember is that 1 milliliter is the same as 1 cubic centimeter. They mean the same thing. So we will be using them interchangeably. Sometimes we'll measure volumes in milliliters, sometimes in cubic centimeters. So you want to be able to do that. We will also in lab be doing an exercise where we will be converting between these sorts of measures and this sort of measure just to show that we know that we can do that. So that is definitely something you will need to do with the cubic meter, and you'll get a chance to practice that on the worksheet. That is it for this module. We will continue with looking at measurements with density, but I'm putting that off until module 3, just because we are covering a lot in this one. So what you would need to do at this point is complete worksheet 2.3. We'll have questions related to everything we've seen here. If you do have any questions, ask them on the discussion board. And at this point, we're done with the module. So if you haven't done anything with the discussion board yet, go ahead and interact with it at this time. And then ideally, go ahead and start the online homework before coming to class on Thursday. And that is it. I will see everyone in a few days.